Hey, I'm Peter Henderson, and the research paper I was tasked to look at in research was the ABS graphene oxide, or ABS-GO. For this research study, the title was Fabrications of ABS-GO Composite Filament for Fused Filament Fabrication 3D Printing, or FFF for short. Authors are listed here. We can find this in the Advances in Material Science and Engineering. Article was released in 2018, and it's about 9 pages long. The scope of the article was basically it aimed to accomplish good quality composite filament for ABS/GO composites, and it basically answered the key question of, is it feasible to 3D print ABS or GO for potential use in engineering applications? Materials used, ABS and ABS-GO composite. They were tested in different materials and parameters to see if the geocomposite would be a good fit with ABS. They tested their heat around the melting points, their viscosity, ultimate tensile strength, Young modulus, and the elongation. Some of the tools used for these testings are listed below, so the 3D printer and the X-ray diffractometer. So the key results from the first study, where they were testing the temperature, they wanted to know how does the melting temperature change between the materials. So you can see to the right in the graph, it shows the heat flow over the temperature. And the ABS and the ABS-GO, they all had the same melting temperature, around 110 degrees Celsius here. And so the key takeaway from this is that the ABS and GO composite can be softened and possibly 3D printed using the same temperature setup used for the pure and conventional ABS filaments, because of the same melting number. For the second key study, basically they were trying to ask the question, is there a uniform temperature for 3D printing of these materials? This is the second way of trying to find this solution. Here on the right, they graph the viscosity over the shear rate of the ABS-GO and the ABS. And it's clear to see here that there's an intersection part where they both have the same viscosity. It's about 0.1 to 1 inverse seconds. Shows the very similar viscosity values, which confirms that ABS and GO could be 3D printed with the same temperature set up for the pure ABS. Now you can see that the ABS-GO starts out with a little bit more viscosity, and we'll get to how this affects this in the summary. Some of the few takeaways here on the paper was that the tensile strength and Young modulus of ABS were enhanced naturally by the GO. Improving mechanical properties verifies the feasibility of 3D printing ABS-GO for potential use in engineering applications. One of the critical things that they said that was a negative effect with the GO additive was that it was a little bit more viscous at the beginning, when it wasn't as hot as, let me go back to this page here. So the viscosity was a little bit higher in the beginning, which made it clog up the extrusion process when it was going through. A way to fix this they had was to wipe it down, clean it off a bit, or to heat up the material a little bit more. So my personal critique on this research paper was that it was very useful, easy to find all the information I needed, clearly stated, and I could follow it pretty quickly. One other thing I would change or critique about it is that sometimes it would have a graph or a image that was 2 pages above and then reference it 2 pages later, and it was hard to go back and forth between those.